need to understand tech. Thank you very much for having me here. Thank you, Sanjay, and thank you to the entire team of Dialogues. It's a pleasure being here, and I run this firm called RAT Lab. I have to always start this presentation with telling people that RAT stands for Research in Architecture and Technology. We do get queries about, designing laboratories and working with animals and all sorts of things. But that's a large part of what we do in terms of the softwares that we use in tech. So I'm just going to briefly talk about parametric design and artificial intelligence. AI is the next big thing, what we've been seeing. And I'm just going to give you a little preview of that at the end of the presentation. Talking of parametric design, that's something that it was absolutely unheard of in the last, like 15 years back, 10 years back. And it was absolutely a new thing that everybody was hearing. Before that, it was what digital, which was the terminology that which was used. I studied in London. I was working with 𝗤𝗲𝘅 architects and worked with robotic companies. Moved to LA, moved back to India, and realized that nobody knows what parametric design is, and that's where our journey started in 2015. And we've done a couple of projects, quite a few projects now with different scales. We've done exhibitions, temples, experience spaces, restaurants, commercial spaces. Quite a few things which have been there, happening, and still going on right now. So just showing you like a visual plethora of things that has happened because of the use of technology, which is parametric design and computational design. So how all of that manifests and articulates into different kind of projects at different scales is really how we code things and using technology. And this is all I'm talking about, the human interaction here, because I'm going to connect this to what computers can do by themselves as well later on. But right now, using computers, we're using technology to design spaces, designing things like, let's say, something as small as furniture, experience spaces, exhibitions. All of these are parametrically designed, and parametric design is not only used as a form finding or a design tool, but also as an analytical tool as well. For example, this is a part of the exhibition where every surface is actually responding to the solar information that is available, and you see all different surfaces with different numbers over there. So we're dealing with a lot of data, we're dealing with a lot of information which we're trying to convert into design in some way or the other. It goes through different kind of analysis, which again becomes a part of the workflow. These are a few more installations, a few slightly larger installation spaces where it's more of an artistic expression that we're trying to bring in. But at the same time, there is a lot of technicalities involved to build these kind of spaces and at a cost which is doable. So that's something that's always a concern, which we try to bring into picture. There's this lighting piece that we have designed. There's this an experience center where you use the light that you see is actually white marble, which we use as stone. So we kind of used a CNC milled white marble and ran an algorithm to create a subdivision of these triangles, which could be replicated on the entire site. And after the algorithm is there, by the click of a button, you could really produce the fabrication data, produce all the pieces, and put them together as backlit elements. This is what the space looked like. And the whole process, just to simplify, is pretty much this: how we use a CNC machine to mill it into these ridges and valleys, which actually create this kind of an idea. Same as we integrated on different restaurants and bars that we've done. We've also used parametric design for collaborating with fashion designers as well, where we use these patterning to design the transparency of a dress, which was 3D printed in parts later on to put together. It was a part of one of the fashion weeks internationally. These are some of the roof structures we're working on. We always prototype things, we always make small models, and that's where all the whole idea of parametric design comes into play, how to make it. At the same time, we also use it to develop a lot of toolkits. For example, this is where we designed something where we have a facade system, and while we were designing it, we could actually translate the entire facade's fabrication data information right into the factory to be able to produce that. And that actually tells us a lot about how we can actually predict a lot of things about, let's say, a facade that we're designing. We can predict the amount of milling time that is required, the amount of time that is required to reduce the facade, and all of that is actually consolidated into like a BOQ right at the beginning while we're designing it. Few of the facade projects and renditions where we 3D printed a part of it. So technology is always integrated into it, basically. So here we're 3D printing a part of the facade for the facade consultant to understand the complexity and the curvature of this geometry. And we would always rationalize the geometry in the form, link that with the environmental data and information. So all of that is a part of the process when we're designing something like a facade or a large-scale building. And this is another ongoing project. You would see like sort of a variation over here. There's basically just 4 kind of panels which are used. And the important part is not just the form of it, which we typically relate parametric with, is actually how we can use that and make the building more efficient. In this particular case, we're using the solar radiation information to understand how this particular design of the facade is going to help the building with the cooling and the heating loads, basically. Also understanding the daylight conditions, what direction would this facade be more feasible in. So we also develop systems like this for a lot of facade companies where we end up creating products related to facade. This was a stadium project we worked on. It's a cricket stadium in Australia. It was a collaboration with an Australian company, and in this particular one, you would see there are solar panels on the roof which are kind of changing in the form, and the change of form is actually articulated onto the whole geometry over there and optimized as per the energy requirements of the building. So we're not only just working on a form or a geometry, we're also trying to give it sort of a meaning, sort of a more important aspect other than just the form. This is a temple we're working on in South India, which is based on a hendecagon. A hendecagon is an 11-sided polygon. The whole idea came in because the clients came in with a very strong ideology of numerology, and they wanted everything with the number 11. Somehow the site was also 11.11 acres. I don't know how they managed that, but that's pretty much how it started for us. And how we kind of ideated it, started the ideation process was understanding what a hendecagon can do and what are the kind of variations we can do to play around with that, which led us to create a sort of an algorithm or a code which allowed us to create these plethora of forms from which we could actually rationalize and understand and choose which out of the this catalog are more suitable, which actually went forward to create this entire structure. And again, then there was architectural and interior resolution, detailing out, and everything was done that followed. This is a theme park which is coming up in Delhi. It's going to be one of the biggest theme parks in India. We're involved in that for the large structures and the sky bridge of that. So you have these 9 pylons which exist. It has a bit of structural complexity. You have a sky bridge coming in, which is hung by cables, which is through the core. And this die-grid is having a cantilevered staircase towards inside. And we could not allow the clashing of the cables and the die-grid to happen. So for that, we had to really model the complexity of it using the kind of tools that we generate in our studio. And developing all the tool sets, we could create an algorithm which allowed us to model the entire thing with something which what we call as parametric BIM, where we're kind of integrating parametric design and the BIM technologies to integrate that into sort of a drawing in a 3D model, which gets us all the information. This is an upcoming project as well we're working on, which has these kind of commercial development and shopping complexes. And so the facade is fairly simple, and then there's a landscape element to it involved, which again kind of takes cues from the facade, which has actually opened up a lot of projects which we're doing as landscape as well, because parametric design has allowed us to actually create something which could be a facade, could be a furniture, could be a landscape, could be an entire system, which can allow us to produce multiple things. So this is all the human thing that I'm talking about right now. This is not designed by computer. This is all designed by humans, which is us, and we're using computers as a tool. But what's happening right now is there is a deep world of AI that is also coming in and emerging as well. I won't talk much in detail about AI. I think most of us are aware of what artificial intelligence is, but there's always been a question about how it can be used. So apparently there are some very interesting tools right now which are kind of open source and anybody can use. Tools like Midjourney and 𝗵𝗵𝗫. These are like tools which work on text prompt. So you basically give a text prompt to the computer and it will create a sort of an information or a drawing, a visual for you basically, which actually is used to create very, very detailed imagery, which is actually giving us a first line information to sort of an architecture that one can predict. So it's all about imagination. You see these various images are actually created by AI. These are not designed. This is designed by the computer. I know it sounds very scary as well that computer starts to design. It starts to replace us as well. But I think the conversation is about how we can actually use these tech as well to kind of create something using something as simple as text prompts. And it works very simple. Like for example, I would give a prompt like, what a city of an ancient advanced civilization in its prime and a 4K resolution. So that's pretty much how it works. And this is what I get in a matter of 60 seconds. Parametric architecture, underwater skyscrapers, advanced civilization, high resolution. And this is what we get. So, and it's really interesting how we can make it learn and do things as well. Now this is what I started with actually. I started to, since you were working on a temple project, I actually, my prompt was temple parametric India. And this is what it gave me. And from that I kind of chose that image, detailed that out into these 4 ideations. And it's not only about the form or geometry. I mean, this is a residential ideation that we did using the tool as well. So again, it's just giving you the first cut information. It's up to the designers how you use it actually. This is again a slightly more detailed one. This is City of London, futuristic London bus. So just by giving this prompt, it starts to give you this information. You change and add a prompt, this is what you get. And you can kind of relate to that, how the computer is creating something. It's a long conversation, we can talk about it in the evening perhaps. Happy to teach you this tool as well. It's open source, free to use. But yeah, I mean, the possibilities are endless. I mean, you can actually create various kind of plans, layouts. And now there are so many interesting things out there. There are tools like Wonder AI, which actually allow you to create this kind of portrait of the Queen when she passed away. And something like, I asked Wonder app to paint pink elephant playing Monopoly, and this is what you get from the image. So it's not just one tool that Midjourney I'm talking about. There's so many tools out there. This is what was on my sponsored post this morning, so I thought of adding that to the presentation. Just the last few videos. This is 𝗵𝗵𝗵𝗵𝗵, a very popular firm in Austria, 𝗵𝗵𝗵𝗵𝗵. So they're using their own project to create a series of their own projects to create new kind of ideations and new visuals of what the new future buildings could be. It can possibly give us some sort of a direction to the firm to kind of what's next for you, and using the computer to assist you to do that, or perhaps just a gimmick, I don't know. So that's something that one has to see. And just at the end, I just want to show you this 1-minute video of what's happening with art as well.
Faroe Islands are an archipelago of 18 islands located in the middle of the vast North Atlantic Ocean. Its isolation meant history's greatest artists never had the chance to visit. But can you imagine how Van Gogh would have painted this? Or how Claude Monet would have painted this? computer can. By using artificial intelligence to analyze billions of pictures, the computer can learn to understand shapes, colors, and the personal style adopted by some of the greatest artists ever known. The computer can create new pictures of the Faroe Islands, just as individual artists might have done in their own style. A carefully curated collection inspired by some of the greatest artists ever living will go on display at the National Gallery of the Faroe Islands at an exhibition opening on the 29th of September. At the exhibition, the audience will also get a chance to create their own images using artificial intelligence. The exhibition raises interesting questions about what art is, what computers may do in the future, and even how Picasso might have represented the Faroe Islands had he been able to travel to see the country. Can you imagine?
So yes, AI is here in art and also architecture, so good luck to all the architects.